This is Alan Lee, podcast from Miss Lewis, Calculus 1, Chapter 2. Number 1, first I'm going to draw the graph. Okay. For number 1, it says using the figure above, determine the function is if the function is continuous at x equals -1. And it wants you to explain your answer using the checklist. The checklist it refers to is first number 1, if f of x, which is f of -1 in this case, is defined. And the way that you find this out is if you find -1 on the x-axis and you see if you see a solid line or a solid dot. And in this case, there is a solid dot. Oh, I forgot a dot. There is a solid dot at 2.5. Or 1.5. So f of -1 does exist at 1.5. For number 2, it wants to know if the limit exists at f of x. So we're going to do from the right. So as x approaches, the limit as x approaches -1 from the right, f of x is equal to, the way you figure this out is you find f of x on the you find -1 on the x-axis, and you come from the right, and there is nothing coming from the right coming toward -1, so the limit does not exist. Number 3 on the checklist, it wants to know if number 1 and number 2 are the same. And since number 2 does not equal and number 1 is equal to 1.5, f of x does not equal the limit as x approaches -1. So therefore, the function x equals -1 is not continuous. For number 2, it says evaluate the following limit. The limit as x approaches 16, 4 minus the square root of x over 16 minus x. First, we're going to use direct substitution and plug in 16 everywhere you see an x. And this will come out to 0 over 0. And this is indeterminate, so therefore you have to change the way that the function looks. So we're going to rewrite the limit, and the way that we're going to change the way that the function looks is we're going to multiply by the reciprocal. And this is going to come out to 16 minus x over 16 minus x times 4 plus the square root of x. The two 16 minus x's, they cancel out, and you are left with a 1. So the way that your new function is going to look is 1 over 4 plus the square root of x. Now you can go ahead and direct substitute again. And this is going to come out to 1 over 8. And that's your answer. For number 3, we're going to evaluate the limit again. The limit as x approaches 0, sine 4x over sine 5x. First, we're going to direct substitute. And this will come out to 0 over 0 again. And that is indeterminate, so we're going to change the way that the function looks. And we are going to do this by changing everywhere that we see sine theta, and we're going to change everywhere we see just sine theta to sine theta over theta times theta. Okay, so this is going to equal sine 4x over 4x times 4x over sine 5x over 5x times 5x. Okay? Your x's are going to cancel out. So this is going to now equal sine 4x over 4x over sine 5x over 5x. And we're just going to separate this into 4 over 5. And since we canceled out the x's, we can now direct substitute again. So the new problem will look like this. Sine 4x over 4x over sine 5x over 5x times 4 over 5. And since we have sine since we have the form sine x over x equals 1, since we know this, then we can go ahead and change both of these problems to find the limit of each. And this is going to change into 1 over 1 times 4 over 5. And this is equal to 4 over 5. And that's your answer. Number 4. It wants us to write the equation for the horizontal asymptote of the function f. So function x is equal to x4 minus x4 minus 3 over 2x4 minus 8. Okay? So first we are going to direct substitute. Well, first we're going to make this the limit, finding the limit. Okay. And now we are going to direct substitute, and this is going to give us 0 over 0. It's indeterminate, so now we have to change the way that the function looks. And the way that we're going to do that is we're going to take out x over 4 on the top and the bottom. Okay, and now we're going to separate the top and we're going to break it up. Okay, and this is what we have now. Now we're going to change x to the 4th, and we're going to change it to the absolute value of x squared times 1 minus 1 minus 3 x over 4 over x to the 4th Now we can cancel out x squared at the top and reduce this to x squared. Now our new function, since we canceled out, now we can go ahead and direct substitute again. And our new problem looks like this. Okay. And now we can direct substitute again. These are going, when we direct substitute, these are going to cancel out because anything divided by infinity is 0. And our answer will come out to 0 over infinity, which is equal to 0. So this is our equation, and this is our answer. Number 5, it says determine where the function is continuous. And the function is 5 over square root of 7x minus 2. So what we're going to do is make an inequality for the radical at the bottom. So 7x minus 2 is greater than or equal to 0. We do greater than or equal to 0 because we want things bigger than 0, because we want to see where the function is continuous. So we're going to solve this like a normal equation. Plus 2, 7x. 7x is greater than 2, divide by 7. Okay, x is greater than 2 over 7. And the way that we would write the answer (2 over 7) infinity. That concludes this assignment.